Guys, I am Muchakwa and I am back with Maths XYZ, and in this lesson we will still be continuing on how to find an equation of a straight line. Remember from our previous lesson, what we did is to find an equation of a straight line using an equation y is equals to mx plus c, and another equation which is y minus y1 is equals to m into x minus x1, of which from the two equations we have m, which is the gradient, and to find the equation of the gradient, or to find the value of the gradient, to say is y is equals to m is equals to y2 minus y1 divided by x2 minus x1. Alright guys, let's just jump into the equation. The equation that we have is y is equals to mx plus c, and another one is y minus y1 is equals to m into x minus 1. And to find the gradient, we use y2 minus y1 divided by x2 minus x1. These are the three most important equations that we will be dealing with when we will be answering a question. Alright, the question that we have is to find an equation of a straight line, of a line, given that this line is parallel to the line which has an equation of y is equals to minus 2x plus 8. And it's passing through a point which has an equation which has a point of 3:7. Alright guys, the question is to find an equation of a straight line, given that this line is parallel to the line which has an equation of y is equals to negative 2x plus 8, and it's passing through the point which has a coordinate of 3:7. Alright, remember when we started with analytical geometry, the introduction, we talked about parallel lines. And with parallel lines, the gradient of the parallel lines, they are always equal. Then if they're saying that the line that we have to find an equation of is parallel to this one, then that means that the gradient of that line and this line that we will be dealing with is the same. That means that from the equation y is equals to mx plus c, we already have the gradient is equals to negative 2 because they are equal. Then it will be negative 2x plus c is equals to y. And to find the value of our y-intercept, we have to use another point in the graph, which is 3:7, to find the value of our y-intercept. Then this one is our x, this one is our y. Then what we have 7 is equals to negative 2 is to 3 plus c, of which here it will be c is equals to 7 plus 6, it will give us 13. And then from here, to substitute it into c, we have y is equals to, this is the equation of a straight line, which is y equals to negative x plus 13, negative 2x plus 13. Alright guys, most important thing about this question was to know that the gradient of parallel lines, they are equal. For this question, we were given this equation, and then we know that from this equation we just have to take out the gradient because it's equal to the gradient of the line that we have to find an equation for. So you still have to remember about parallel lines, perpendicular lines, collinear lines, and also the midpoint, and so forth about analytical geometry. Alright guys, let's do another question again, of which in this question we are also asked to find an equation of a straight line, given that the straight line that we have to find an equation for is perpendicular to the line which has an equation of y is equals to 1 over 3x plus 2 and minus 2, I mean to say, sorry guys, is perpendicular to 1 over 3x minus 2, and it's passing through, and sorry guys, it has a y-intercept of is equals to 6. Alright guys, about perpendicular lines, remember the first gradient and the second gradient, when you multiply them together, it must give us negative 1. Though that's the rule of a perpendicular line, that m1 multiplied by m2, the product of this must be equals to negative 1. Then this is the rule of perpendicular lines. For this one, we are given the first gradient, which is 1 over 3, multiplied by the second gradient, which this is what we're trying to find, is equals to negative 1. Then that means that our m2 is equals to negative 3. Alright guys, and then for this one we already have our m2, which is equals to negative 3. We just have to substitute it into this equation to find the equation of a straight line. And lucky enough, for this question we are already given the y-intercept, which is equals to 6. Then we just have to substitute everything, and that will be the equation of a straight line. Then we'll have y is equals to mx plus c, which is equals to negative 3x plus 6. This is the equation of a straight line that we have to find. Alright guys, I hope you understood this one as well, that if you are given an equation which is perpendicular to the line that you have to find an equation for, what you need to do is to multiply the two, is to use this equation, which is m1 multiplied by m2 is equals to negative 1. Then you substitute the gradient that you are given and you equate the 2 into negative 1. Then that will give you the second gradient which you are looking for. And then if maybe for this case we are given another point in the graph, what you need to do is just to substitute x and y to find the value of c. Alright guys, I hope that will be easy enough for you guys. Alright, let's do another question, which is also still to find an equation of a straight line. For this equation of a straight line, it says we must find an equation of a straight line which is parallel to the x-axis and passes through the point 5 is to negative 7. This line is actually parallel to the x-axis, and it's passing through the point 5 is to negative 7. Alright guys, okay, if they say they're talking about parallel, that means that the two lines there, the x-axis and this line, they actually have the same gradient. Alright, then let's draw this thing out. So if we have this, it's 2, it's 4, it's 6. Alright, if we have 2, 4, and we have 6 and 8 there. Then we have our 5, which is 5, it will be somewhere there, and our 7, it will be somewhere there. So if they are saying that this line is actually parallel to the x-axis, that means it's passing right there. This is our x-axis, and this is our line which is passing through the point 5 is to negative 7 and is parallel to the x-axis. Then the equation of this line, it will be equals to y is equals to negative 7, just like that, because it won't go anywhere. It will always be at y is equals to negative 7. So this equation will pass at 7 is to 2. It will pass as 2 is to negative 7. It will pass at 3 is to negative 7, all going there up to infinity on the x-axis, and also in the in the negative x-axis up to infinity. Alright guys, what you need to do to understand more this question, sometimes you have to draw it down so that you can get a clear view of how it looks like. For this one, we know that we are told that it's actually parallel to the x-axis. So something which is parallel to the x-axis should be going straight up to infinity in the being parallel to the x-axis, like what we just drew here. And from here we can conclude that the equation of this line is actually y is equals to negative 7. Alright guys, let's do another one, which will be our last question for today's lesson. Alright, for this one it says we must find an equation of a straight line which is parallel to the y-axis. Again guys, that one was parallel to the x-axis. This one is parallel to the y-axis. Parallel to y-axis, and it's passing a point again of 5 is to negative 7. Alright, so if we have to do this, drawing it out, it will be, again, it will be 2, 4, 6 guys, and 8. Just to have a clear view of how this will look like. So from here we have 5 and we have negative 7, which is our point there. So it's either our line goes through that or the side. But then they're saying it's parallel to the y-axis. That means that our line, let me just use another marker for this one. This will be our line. Sorry, it has to pass. Let's assume this is our negative 5. It's not drawn up to scale. So this is our line because it's parallel to the y-axis. And this is the point which is passing at, which is 5 is to negative 7. So from this one, we can now conclude that the equation of this line is equals to x is equals to 5. This is the equation of this line. So if you're given something parallel to y-axis, parallel to x-axis, it's better to just draw the thing down so that you can have a view of how it looks like, and from there you can conclude on your answer. Like for this one, we can now tell that this line, which is parallel to the y-axis, the equation of this line, it will always be x is equals to 5 going up to infinity. So it will be it will always have 0.5. Like for this one, it's 5 is to negative -7. There will be 5. There will be 5 is to -4. There will be 5 up to infinity, and also 5 into positive infinity on this quadrant. All right, guys. I hope you understood this lesson as well. And if you didn't, please drop us a comment on the comment note, and we'll have a follow up on it. Don't forget to subscribe to Maths XYZ so that you can get daily notification when we upload videos. Thank you.